Morning. Another fun time today. We're going to talk about something I know you're all familiar with, and that is texting. The question is, how many texts is too many texts? Oh, darn phone. It might be Mrs. Johnson. Let me pause this for a minute. Oh, it stopped ringing. How nice. Okay. Now, we have take out your notes, or let me share a screen here so we can look at them together. Your note paper that is titled, How Many Texts Are Too Many? So, really might be Mrs. Johnson. Let's see, just a second. Okay, so you have your note paper out. It says, how many texts are too many? Let's take a look at what it says. Recently, Rachel was texting during dinner. I'm sure that's something you never do, right? But Rachel was. Rachel's mother wanted Rachel to interact with the family instead and told Rachel she was texting way too much. Rachel disagreed. Again, I'm sure you never disagree with your mother, but Rachel's a rebel, I guess. So Rachel disagreed, saying she didn't text any more than anyone else. Since they couldn't agree, Rachel, her mother, did exactly what I know what you would do if you disagreed with your mother. Okay. They decided to collect data on the number of texts people send on any given day. Do a little research here. They each asked 24 of their friends. 24 friends? Man, who has 24 friends? I don't think I've had 24 friends in my entire life. Oh, well, maybe some of you do. I had a friend once, though, I think, but not 24 of them. So I can't relate to that. But at any rate, they had 24 friends. So they each asked 24 of their friends the following question. On average, how many text messages do you send in one day? These were their 48 responses. So we got there in the table, the 48 responses from the 48 friends, 24 from Rachel, 24 from her mother. So let's look at part A. Once the data was collected, Rachel created a histogram of the number of texts as shown here. Very similar to what you would do in the same situation, I'm sure. Create a histogram. I'm going to move this up out of the way a little bit. Okay, so we created a histogram. Based on this histogram, how many texts is reasonable for Rachel to send in one day? You're going to provide a mathematical justification for your answer. So press pause here. And while you're on pause, decide what you think would be a reasonable number of texts for Rachel to send in one day. And provide some mathematical justification. You've got all the information right here in this text. So provide some mathematical justification here. Okay, go ahead and pause your video. After you have written down on your paper how many texts you think it would be reasonable for Rachel to send and justified it with some sort of mathematics, then press play and we will go on. You know, just as I look here, the most responses were between 0 and 20. So if Rachel's argument was she didn't text more than anybody else, well, looks like the majority, at least the most responses here out of their 48 friends, was between 0 and 20. So is that the reasonable answer for Rachel? Okay, I imagine most of you think not. And so what would you do? How can Rachel argue that 0 to 20 is not reasonable for her? Because here's the math, okay? The statistics say, just a side note here, when you're talking statistics, remember, statistics don't lie, but statisticians do. So this is a very important unit that we're talking about here in statistics because people throw statistics up all the time. You've got to be very careful when people are quoting statistics to prove their point. You don't know where they got the statistics from. You don't know, how accurate they are. There's a lot of things you don't know that you have to take into consideration. You don't know the way the questions were worded, if it was a survey they were talking about, and that sort of thing. I get surveys answered, especially during election time, get survey calls all the time. And I can usually tell who's paying for the survey by the way the questions are asked. So, when people start quoting statistics to you, just be careful. Yes, they are useful, but you do need to have some background type of information and put them in context before you start believing everything that people try to prove to you through statistics. Okay, now that you've done that, and I'm not going to talk about this anymore today. We'll talk about this more tomorrow. Actually, it'll be Mrs. Johnson, I believe, that'll be talking about this more tomorrow when we analyze this further and dig deeper into these numbers and these statistics. So I'm going to slide this up so we can see the lower part. And here's what we want to do now. Create a box plot of the same data below. You remember box plots from, I don't know what grade you did them in, but you've done them before. You need to know the quartiles to make a box plot. Remember the quartiles, the root word quarter, so you're going to divide it into fourths, your data. We have 48 responses here. Okay, so the median, which is the middle, of course, which is quartile 2. I'm just going to write it up here. The median, or quartile 2, will be, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So the middle will be here, halfway between 70 and 80. Now I believe, this is our median, our second quartile, halfway between 70 and 80, I believe is 75. If you don't believe me, you can do the math. You can add 70 and 80 together and divide by 2 to find out what that middle is, but I believe it's 75. Okay, so there's our middle. The first quartile, or the lower quartile, is the middle of the lower half. So there's 24 here, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so the lower quartile is right here between 6 and 6, which I believe is 6. The upper quartile, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that would be between 150 and 150. So that's easy enough math. I can even do it. That would be 150. Okay, we need to know the minimum. The minimum, or the smallest number. Now these are in order, so it would be 0. We need to know the maximum, or the largest number. And again, in order, it's pretty easy to find. It is 275. Okay, now we have all that information. We're ready to draw our box plot. So we'll put the minimum on. The minimum is at 0. I'm going to do it above the line so we can actually read it a little bit. Okay, the lower quartile was at 6, Q1 at 6. Oh, what do we have here? 5, 10, 15, 20. We're going by 5s. So 6 will be just about right here. And we want to label it. This is 0, this is 6. And there's our whisker. Okay, the median was at 75 right here. And the upper quartile, 150 right here. This is 75. This is 150. And I should have written them down, I suppose. You know, Q1 was 6. Q2 we have, so we want Q3 is 150. Okay. And then the maximum is 275, clear out here for our max, 275. And then of course, where's my straight edge? Somewhere we will draw our box. So there's our box. And then of course, we have this guy clear out here. And there is our box plot. Okay, so now that we've drawn it and we have labeled it, remember what this means. Since the quartile is divided into fourths, there's a fourth of our data. There's a fourth, there's a fourth, there's a fourth. So kind of interesting there. I mean, look at all those low numbers. Fourth of our data is less than 6. Less than 6. So Rachel, we'll have to see what kind of arguments you can come up with to help Rachel to text more than 6 to 20 times. Okay. So there it is. Now, what conclusions can you make based on this, on the box plot? Well, you've got one thing that I just pointed out, 25%, 1/4, 25% of the people sent 6 or less, sent 6 or less texts. That's not very many. You know, you could say, well, there's a high variability. I mean, look, we go from 0 all the way to 275. So let's, and then measures of variability, one of them is range. So let's talk about the range. The range, remember the range for the whole thing is highest number, subtract the lowest number. So the range here is 275. The interquartile range, which is the range of the box, the interquartiles, we call it the IQR, the interquartile range. Oh, let me move it up a little bit so we can see it better. The interquartile range, the IQR. Well, that would be 150 minus 6. So 150, the top of the box, or the third quartile, minus the bottom end of the box, 6, or the first quartile. And that is 144 for those of you that can subtract that. Okay, now look, that box is pretty long. That's a pretty wide range. That tells you it has a high variability. These two things right here tell you there is a high variability. Which means it varies a lot, obviously. Some people didn't text, a whole bunch of text less than 6, and then some people text a whole lot. I don't know how you do 275, sit there all day, I guess, and text. But kind of interesting. Now, when you're looking at this too, remember this is 25%, 25%, so 50% less than 75, 50% more than 75. You know, there are a lot of things we can conclude here. It wanted us to write 2 or 3 sentences on conclusions. So I may stop right there, but we could write 50% of the data is below 75. Could have written 50% of the data is above 75. Okay? We could talk about 275, it's way out there. Perhaps that might be an outlier. Now, I don't know because I haven't done the calculation. We haven't talked about outliers at all, but It could be. Maybe that's just one freak among our friends, but we'll have to wait and see. So I'm going to stop there with those observations. Like I said, tomorrow, hang on to this, because tomorrow you're going to discuss this. We're going to discuss this more, except I think Mrs. Johnson's going to talk about it tomorrow. And we're going to look at ways that maybe Rachel can come up with some argument to help her out. Otherwise, she can be stuck with not very many texts, maybe even as many, 6. But we saw from our histogram that maybe 0 to 20. So tune in tomorrow. We'll talk about this some more, give it some thought, and see what you can come up with as to how we can help Rachel get to do more texts. Okay, good luck with that, and we'll talk to you later.